check 7.4 there. Check 7.4. I think this will probably be the last problem. 7.4. In 7.4, the question is, prove that ATB, triangle ATB, this triangle, is similar to triangle EPB. Check triangle ATB, check triangle EPB. Then we are now at 7.4. What is common about the two triangles? Triangle ATB and triangle EPB. Already you've got angle T3, you've got that one, it's 90 degrees. It's 90 degrees. And check B1, this angle B1 is equals to T1. T2 here, according to tan-chord theorem, T2 is equals to angle A. Check angle T2 is equals to angle A according to tan-chord theorem. Check the triangles that you are working with. Triangle ATB. This triangle ATB and triangle EPB. And triangle EPB. We want to prove that the two triangles, we want to prove the two triangles to be similar. And for two triangles to be similar, I said, like I indicated earlier, you only need to prove two pairs of angles to be equal. Once you've got the two pairs equal, then the remaining pair will automatically be equal. So already you've got angle T3 and angle P, which is 90, which are both equal to 90. So we look for one more pair of angles that are equal. And remember, B3 from the earlier workouts, B3 is equals to the whole of E. Thank you. Let's work it out. Check angle T2. Angle T2 is equals to angle A. See? T2 is equals to angle A. Give me a reason for that statement. Angle T2 is equals to angle A. Why do I say angle T2 is equals to angle A? According to tan-chord theorem. Tan-chord theorem. Tan-chord theorem. T2 is equals to angle A. But look at angle T2 again. T2 is equals to A1. The very same angle T2 is equals to A1. Why? Remember, in number 1, we have proven that TEPB is a cyclic chord. So if TEPB is a cyclic chord, it means T2 and E1, those are the angles subtended by the same chord. Angles subtended by chord BP. Angles subtended by the same chord, and that chord is BP. That's why we say T1 is equals to T2. Thank you. Now we start. Let's work out in the two triangles. Let's focus in triangle ATB and triangle EPB. Number 1. This is the information that we have just proven. T2 here. T2 is equals to A. T2 is equals to A1. Look, T2 is common. T2 is equals to A1, T2 is equals to A. So in the two triangles, it therefore means in triangle ATB, angle A is equals to angle E1. Both equals to T2. Angle A is equals to angle E1. Both equals to angle T2. We look at triangle ATB. Triangle ATB. We said T2 is equals to A. We also said T2 is equals to E1. Therefore, it means E1 is equals to angle A. Angle A is equals to E1. Both equals to angle T2. Thank you. That's the first pair. The second pair, remember, you said angle T3 is equals to angle P, and they are both equals to 90. Both equals to 90 degrees. T3 is equals to P, both equals to 90 degrees. Then you look in triangle ATB. The remaining angle is B3. In triangle ATB, We have talked of angle A, we have talked of angle T3, we haven't yet talked of angle B3. Therefore, the remaining angle will then be angle B3 will then be equals to, then you look in triangle EPB. In triangle EPB, we have talked of angle P, we have talked of angle E1. Then the remaining angle will then be angle B1. Then we can conclude. Triangle B3 equals to B1. Therefore, triangle ATB will then be similar to triangle. Check ATB will be similar to EPB. EPB. Order is very much important. A is equals to A, T is equals to P, B is equals to B. Even the order here, the order in which you take those letters must be the same. Why do we say they are similar? Angle, angle, angle. I think we have proven that part. That was 7.4. Prove that ATB is similar to APB. We have proven that ATB is similar to APB. The last part of the work problem. Here we are. 7.5. We have already proven that ATB is similar to angle EPB. Why do we say the two triangles are similar? We've talked of T3, it's equals to 90. We've talked of angle A, it's equals to E1. We've talked of angle B3, it's equals to angle B1. So they are equiangular. 7.5. Prove that twice BP squared is equals to BE multiplied by TB. It is always very much important to note the given information. Remember earlier on we were given that BP is equals to OB, BP is equals to OB is equals to OA. Those were the radii. Thank you. Now we want to prove that twice BP squared is equals to BE multiplied by TB. Why do we have to take the sides in order? Because it makes the proportion easy. Let's check. It means if you can check it AB equals to AO plus OB. If you take AB over, then you check on the TB. Order is very much important when writing that the two triangles are similar. Because if you take AB over TB, that will be the same as, instead of AB here, you can take EB, which is the same as BE over, we set TB here, then here will be PB or BP. BP. And then you cross multiply. And then you cross multiply. Let's cross multiply. If you cross multiply here, you've got AB multiplied by BP, which will give you multiply here TB by BE. Then if you multiply, you'll have BE multiplied by TB. Let's go to the diagram. Let's go back to the diagram. We are at this stage now. We've got BP, and remember the required to prove part, it has got BP squared. Everything, we already have BE multiplied by TB. We already have BE multiplied by TB. But we've got AB and BP here. So it means AB and BP, everything must be expressed in terms of BP. Now let's check. Go back to the diagram. Check AB. AB. AB basically is the same as AO plus OB. That's AB. AB is the same as AO plus OB. And then you multiply by BP. Remember, the product is still BE multiplied by TB. Check AO. From the given information, it was given that BP is equals to OB is equals to OA. Then what do we do now? Instead of AO, we write BP plus, we've got OB, we still write BP multiplied by BP. The product will still be the same as BE multiplied by TB. BE multiplied by TB. Then you add the two, BP plus BP. Then if you multiply, you add BP to BP, you've got twice BP, going to multiply it by BP. The product is still BE multiplied by TB. Therefore, you multiply throughout, then you've got 2BP squared, which will then give you BE multiplied by TB. Then we have got the required to prove part. Twice BP squared equals to BE multiplied by TB. Thank you. I think I've come to the end of the session for today. And I still believe in mathematics, we need to practice. For you to master the theorem, you practice a lot. Practice makes perfect. We have done almost about 8 geometric diagrams for today, and it's a lot. We've been practicing and practicing. I believe if you can continue practicing, those theorems will be part of you. You'll just know where, when to apply a theorem. On that note, let me take the opportunity to wish you well in this coming test, and good luck even for June and September, and ultimately for the end of the year examination. I wish you all the best, but you need to work hard. You need to practice mathematics. Mathematics is a subject that needs to be practiced. Without practice, there is no way you can do well in mathematics. I wish you well and good luck. Thank you.